Hi, welcome to this lesson on calculus. What is the derivative? Let's have a look at question 3 for deriving from first principles. So again, the first derivative, f prime x, is defined as the limit as h tends to 0 of the average gradient formula. So let's write that down. All right, and then as usual, I'll perform my algebraic gymnastics on the side. Okay, so f of x is given as the square root of x. So now we have a surd. So we need to be careful when we're dealing with surds and our algebraic rules. Okay, what is f of x plus h? Well, wherever there's an x, I need to replace it with x plus h. So this becomes the square root of x plus h, not the square root of x, then plus h. That's not the same thing. Okay, so wherever the x was encapsulated under the square root. So f of x plus h is the square root of x plus h. All right. Then, if I do f of x plus h minus f of x, well, that's just the square root of x plus h minus the square root of x. Now, there's not much simplification I can do here now in either surds. So what I'm going to do is I'm going to look at what happens when I divide both sides by h here, because that's the structure here. Well, if I take the limit as h goes to 0 automatically, I'm going to be left with the square root of x plus 0, which is the square root of x, minus the square root of x all over 0. So I get 0 over 0, which is undefined. It's indeterminate. Okay, so how do I work around this? I know that there's a great algebraic technique that I can use from my algebraic toolkit when it comes to surds, and that is rationalizing the surd. Okay, so remember, how do we rationalize? We're multiplying by 1. That's the trick. But we look at the surd here, where the surd is, and we multiply by the conjugate. So that means we're going to multiply this entire expression by the square root of x plus h plus the square root of x. And we do that the same thing in the denominator, because essentially this entire expression here is 1. Okay, this entire expression. So we're not changing the expression. So what does this become? Well, so let's write it out algebraically neatly so we can see what we have. Square root of x plus h minus the square root of x times the square root of x plus h plus the square root of x. All over, in the denominator on the left, it's h, and then times the square root of x plus h plus the square root of x. Okay, so that plus, that h is from there, right? Remember, we're multiplying, so the denominators get multiplied as well. All right, so let's expand this. The square root of x plus h times the square root of x plus h. So that's essentially the square root of x plus h squared, because you're multiplying something by itself. Then if we expand there, we're going to have plus the square root of x times the square root of x plus h. Then if we expand here, it's minus the square root of x times the square root of x plus h. And then we have minus the square root of x times the square root of x is just the square root of x all squared, because you're multiplying square root of x by itself. Okay. So now that we've got that, we need the denominator terms. Okay. So let's just get our pen back up here. There we go. All right. Okay. So now that's all divided by h times the square root of x plus h plus the square root of x. So I haven't manipulated the denominator yet. So let's see. Can you see that this term here, these are like terms. One is a positive, one's a negative. So they will cancel out. That's the whole idea of rationalizing your surd. So the square and the square root will undo each other. So you're left with x plus h. Then minus the square root of x all squared is just x, all over h times the square root of x plus h plus the square root of x. Okay, and then here in the numerator, x minus x will cancel, so you're just left with h all over h times the square root of x plus h plus the square root of x. Okay, so lots of algebraic gymnastics. Make sure that as you go from one step to the other, it is making logical and algebraic sense. Now, because everything's multiplication, the h's will divide, and essentially this entire expression that you're left with now, so it's the limit as h approaches 0 of, so it's going to be 1 over the square root of x plus h plus the square root of x. Now I can evaluate, I can substitute that value of 0 for h. So I get x plus 0 in the denominator there, square root of it, plus the square root of x. So that's 1 over x plus 0 is just x. So it's the root of x plus the root of x. I have two amounts of these common terms. So I have 1 over 2 amounts of root x. Okay, so that is the final solution for the derivative of f of x equals square root x. It's equal to 1 over 2 times the square root of x. So the entire numerator is just 1, and the denominator is now 2 times root x. Okay, so you can sort of see the pattern. Whenever square root of x, there's a surd there, and suddenly the surd is now in the denominator. So again, we'll see from the power law why this happens as well. Alright, so that's how we would solve this type of question. I'll see you in the next one.